We're going to teach mathematics. Let's solve this problem. A man circles 11 kilometers north, then 21 kilometers east, and then 9 kilometers north. How far is he from his starting point? You must really need to understand the question. A man circles 11 kilometers north, then 21 kilometers east. Now, the starting point is a man circles 11 kilometers north. So we need to pick a point and say this is where the man is. So let's say this is the man. This is the man. This is the starting point. Now at every point you have the north. This is the north, the east, the south, and the west. So the man is here. This is where the man is. A man circles 11 kilometers north. That means northward, upward for 11 kilometers. So let's say that is 11 kilometers. And then this is where the man is. The man is here at this point. So label this 11 kilometers. Now at this point where the man is now, this is the north, the east, the south, and the west of his current position. Then 21 kilometers east. That means it moves in that direction of eastward. This is the east for 21 kilometers. We expect that 21 kilometers should be longer than 11 kilometers. So we're just using our discretion there. And then we stop. Let's cut this point. This is where the man is now. And so this is a distance of 21 kilometers. Now, the man didn't move there. It didn't stop there. Now, at this point where the man is, this is the north, the east, the south, and the west. Now, it continued, and then 9 kilometers north. So the man moved 9 kilometers due north from his current position. 9 kilometers is supposed to be shorter than 11 kilometers. So let's say we have this. And then we stop here. So now currently, the man is here. The man is here. And this is 9. This is 9 kilometers. So this is where the man is now. The man is at this point. So what is the question? How far is he from his starting point? So this is the starting point. So how far is he to where he is now? How far? What is the distance from where the man is to his starting point? So that's what we are asked to find. Okay, so we can always start by saying that, okay, let's the distance of the man from the starting point let the distance of the man of the starting point be x kilometers. So we are calling this x kilometers. That's the distance of the man. Now this is where the man is currently. The man is here. That's where the man is. So let's label all of the points so that it's easier for us to describe. So let's call this point A, where he started from, to point B, to point C, and then let's call this point D. Now, looking at this diagram, we can make a little bit of adjustment to this diagram so that it makes some more sense to us, and then we are able to solve and find this distance. Now, the adjustment we just want to make to this diagram is we can extend this line. When we extend this line further and then extend this line here downward, we would see that we'll be able to form a right-angled triangle such that this is going to be perpendicular. This will be at 90 degrees, and so we have a right-angled triangle. Now, we extended that side further because this line is a parallel line, so we can extend it. And then this other one we did that we brought down is a parallel line, can be extended. So we have a right-angled triangle. let's call this point E. So that point is point E. What we are looking for is the distance of the man from the starting point, and we've called that x kilometers. So now let's look at all the other informations that we have here. Now when you look at point A to point B, that is 11 kilometers. All of this is 11 kilometers. Now this distance from here to here will be exactly the same distance from C to E. So if all that we have here is 11 kilometers, then we can say that this also too is going to be 11 kilometers. CE is going to be 11 kilometers. Why? Opposite sides are equal. And then if CE is 11 kilometers and this is 9 kilometers, then we can say that the entire length DE will be 9 plus 11 kilometers, and that is 20 kilometers. All that we have here is 20 kilometers. Also, when you look at BC, line BC, this is line BC, B and C. Yeah, line BC is 21 kilometers, and that is the same as line AE. Line AE, look at line AE. Opposite sides of that rectangle formed there, opposite sides of a rectangle are equal. So this is also going to be 21 kilometers. And so in this rectangle triangle now, we have the value of length AE. A to E is 21 kilometers. D to E is 20 kilometers. So I want to extract that diagram out, that right angle triangle. When I do that, this is going to be, I have this line, which is my DE. I have this, which is my AE. And then I have this. This is my AD. So this is AD. This entire length is 20 kilometers. This entire length is 21 kilometers. This is at 90 degrees. And so this is the distance we're looking for, the distance of the man from the starting point. So this is a right angle triangle, and then to find a side in a right angle triangle when two sides are given to you, we make use of the Pythagoras theorem. The Pythagoras theorem states that in a right angle triangle, the square of the length of the hypotenuse side is equal to the sum of the squares. So the hypotenuse side is that side facing this 90 degrees. This is the hypotenuse side. This is the hypotenuse side. We have this to be the hypotenuse side. So we have x squared will be equal to the sum of the squares of the other two sides, 21 squared plus 20 squared. So we have x squared equals to 441 plus 400. So x squared is 841. And then when we take out the square, we find the square root of the other side. This is going to be square root of 841. And x, which is the distance of the man from the starting point, is 29 kilometers. And that's the